Okay guys, so this is the recording of the non-calculator prelim paper. Okay, so first question, we've got mixed fractions. Okay, so if you're looking for the section in the handout, it's section 2.5. On the whole, done pretty well. Okay, so on the whole, it was done pretty well. Okay, so looking at this, we've got one whole, okay, and 2/5 additional, and then minus one whole, and then 1/4. Okay, so that one whole here is represented by 5/5. Okay, and we're adding on the 2/5. Okay, this is minus the one whole here, which is 4/4, and we've got a remainder of 1/4 there as well. Okay, so when we put it all together, we've got 7/5 over 5/4. Okay, and then we're just going through our fraction. Okay, so we're doing a subtraction with just a normal fraction. Okay, so in this regard, cast smile, multiply, and watch the signs. So 7 times 4 is 28, minus 25, all over 20. Okay, we're multiplying the two bottom terms to get the same denominator. So that gives us 3/20, and that cannot be simplified any further. Okay, that's it. Okay, so the most important stage is that breakdown there. Okay, recognizing that one whole is going to be whatever the denominator is. Okay, top and bottom, plus your remainder. Okay, also be careful of the symbols. Other than that, it was reasonably well done. Okay. Question 2, again, reasonably well done across the board. Quite a few mixed up some symbols part way through it. Okay, so let me just copy that out. If you're looking for the section, it's section 5.11. Okay, so section 5.11. Okay, so we're just going through every term is multiplied out. 2x cubed minus 6x squared plus 8x. Okay, watch that symbol. Then we've got minus 3x squared minus 3 times minus 3 gives us plus 9x, and then minus 3 times 4 is minus 12. And then it's just a case of tidying up. Okay, the like terms. So like terms, just one with the same index to the same power. So all the x cubes, all the x squareds, all the x's, and just the whole numbers. Okay, so quite well done. However, a few people mixed up the sign when they were multiplying out. Okay, so just be careful of the sign there. That's 3 marks. Okay, nice way to get 3 marks. Next question, question 3, was pretty poorly done across the board. Okay, now it has been a while since we've done completing the square. Okay, but it's an important skill that you learn. Okay, 2 seconds, just writing it out. So x squared plus 4x minus 3 in the form of x plus a squared plus b. This in the form of that, okay, you need to be aware and you need to be confident that that is completing the square. Okay, that x plus number squared plus another number is completing the square. That's what they're looking for you to do there. Okay, so we just go through that process. Oops. Okay, completing the square process, put in your brackets the x term, or plus, okay, and then it's b over 2, squared that bracket, minus b over 2 squared plus c. Okay, so where are those letters b and c coming from? Well, we know that we can write quadratics in that form. Okay, so ax squared plus bx plus c, that's where those terms come from, and we can substitute them in. Oops. Okay, minus 3 because that term is minus 3. Okay, so we're substituting in b where there's b's and c where there's c's. Working through that, x plus 2 minus 2 squared, which is 4, minus 3, and that's your answer. So completing the square, section 7.1, important. Okay, it will always come up. Question 4 is a factorization question. Okay. So question 4, we're looking to factorize that. Okay. So x squared minus x minus 42, and we're going through our CDT process. There is no common factor. It's not a difference of two squares. It is a trinomial. Okay, we are adding two numbers together to get negative 1. Okay, this term in here. Remember, we don't write the 1, but essentially there's a 1 there. Okay, so we're adding them together to make negative 1, and we're multiplying them together to get negative 42. Okay, that seems like quite a big number. You go with it. Okay, to get a negative, we need a positive and a negative, or a negative and a positive. Write out the working, please God, write out the working. Okay, so positive or negative, negative and positive. 1 in 42 would be a factor, 2 in 21, 3 in 14. Okay, and then 6 and 7. Okay, 6 times 7 equals 42. Now we need to get a negative, and we need to end up with negative 1. So we're going to have a negative 7. Okay, so 6 minus 7 is going to give us a negative 1. So that's our factors. Okay, that's it. 2 marks. Show your working. Question 5. Through a lot of people. This is section 21. Okay, trig graphs. What we're looking at, okay, the number in front of the sine, cos, or tan is your amplitude. Okay, that will set your maximum and minimum. Okay, so that's how high and low where your peaks and troughs are going to be, that number in front of it. Sine, cos or tan, that's your shape. That will give you your start point and your end point. That's where the milestones are important. So we need to know the milestones for the graph of sine, cos and tan in between 0 and 360. Okay, where does it start? Where is the maximum? Where does it cross x? Where's the minimum? Where does it finish? Okay, we need to know them for sine and cos. And then the number in front of the x is your phase. How many waves, how many complete waves are we getting in between 0 and 360? We're getting 2 complete waves. That means our milestones we're dividing by 2. Okay, so let's draw this out. Okay, so you need to be aware of the milestones for this. Okay, so sketch the graph of y equals 3 sine 2x in between 0 and 360. Okay. So you're given your y and your x. You don't need to do it perfectly accurately. So we need to split that. So that's going to be 0. So where the x and y axis cross is your 0. That's where your graph starts. Okay. Find your finish point, 360, and then break it up. Okay. So you've got 180, you've got 90, 90. If we just had a normal sine graph, that would be our milestones. Okay, if we just had our normal sine graph, that 90, 180, 270 would be our milestones. Okay, maximum, x, minimum, finish. That is our y equals sine x. Okay, amplitude of 1, 1. We want to draw y equals 3 sine 2x. So we want a sine wave. It starts at 0, it finishes at 360. The milestones are getting divided by 2 because there's 2 full waves, and the amplitude is 3. So it goes up to a maximum of 3 and down to a minimum of -3. Okay. So we've got that set up. Okay. Our milestones are going to happen. Instead of every 90 degrees, it's 90 divided by 2. That number there. Okay. So there's going to be a milestone every 45 degrees. Okay. So we can go back to our graph and we can mark on where all the milestones are going to be. There's going to be a milestone at 45, there's going to be a milestone at 135, and a milestone at 180, 225, 215, no, 315. Okay, that's because we're going to get one full wave between 0 and 180. Okay, we're going to get 2 full waves in between 0 and 360. So that means we're going to get one full wave between 0 and 180. Okay, all your milestones are going to happen at every 45. So it starts at 0, as every sine graph does. We're going to get a peak at 45. It's going to cut through at 90. We're going to get a minus at 135, or a minimum at 135, and then it's going to finish at 180. The amplitude is going to be 3, and your minimum is going to be -3. That is set by this number. Okay, so one full wave for a sine graph. Sine starts at 0, peak, cut 0, minimum, finishes at 0. Okay, cos starts at its maximum, goes to a minimum, and then finishes at its maximum. Know the difference between sine and cos. Okay, that's not the end of it. We're going to get another full wave. Two full waves in between. Okay, so one wave, two waves. There's a milestone every 45. Label, label, label. You get a mark for labels. Label the maximum, minimum. Label your milestones. Okay. Question 6. Find the equation of the straight line. Okay, so you're not given the image, you're just given 2 points, and we need to find the equation of the straight line. Now the equation of the straight line is in the form, y equals mx plus c. That is your equation of straight line. Okay. M is a gradient. C is where the line cuts the y-axis, or our y-intercept. It could be known as your y-intercept. We have an formula to find a gradient, okay, in which we can use our 2 points. Okay, that is x1, y1, that is your x2, y2. Okay, and we're just substituting that in. So y2 is 5 minus 4. x2 is 3 minus 2. Minus 4 makes that positive. Okay, so you're going to get 5 plus 4, so you're going to get 9 over 1. So your gradient is 9. Okay, so y equals mx plus c, y equals 9x plus c. Okay, so what are we missing? We're missing this c. Where does it cut the y-intercept? Where does it cut the y-axis? Okay. To allow us to do that, we pick one of the points. So pick one of the points. So I'm going to pick B, which was 3 and 5. Okay. That is your x coordinate, and that is your y coordinate. We're going to take the x coordinate put it in x. We're going to take the y coordinate and we're going to put it in y. And then we're going to solve for c. It's as simple as that. So y is 5 equals 9 multiplied by 3 plus c. So we've substituted in those coordinates. So we've picked one of the points. Okay, that point has no negatives in it, so we can pick that one. Okay, substitute it into that expression and then solve for c. 9 times 3 is 27 plus c. Okay, I'm going to flip this around, so it's c plus 27 equals 5. I have not changed anything. That line and that line is exactly the same. Okay. C is equal to minus 22. So y equals 9x minus 22. Okay, that's your expression for your straight line. Now you can do a check. This is the additional bit by subbing in a, which was 2 and negative 4. That's your x term, that is your y. If you've got it right, this should work. So if we substitute in negative 4 equals 9 times 2 minus 22, we should get the right answer. So negative 4 equals 18 minus 22. Negative 4 equals negative 4. So it works. The left-hand side equals the right-hand side. Okay, now that bit is just a check. You don't need to do it. If you've got time at the end, whatever. Okay, do it in the additional. That's the process though. Finding the gradient using the 2 points you get given. Putting the gradient in and substituting in one of the points. Okay, one of the given points. And it will give you, spit out your answer. Question 7. 7 is tough. Okay, so you're looking for volume of a cone. You're given that at the front of the paper, the expression for that. Most people pick that up correctly. Okay, you're given a height, which is 12 centimeters. You're given a diameter, which is 6, which means the radius is going to be 6 divided by 2, which is 3 centimeters. And you're given pi, which is equal to 3.14. Okay, remember this is non-calculator, so we need to use multiplication skills here and understanding. Okay, so that's what we're starting with. This is given at the front of your paper. Okay, that's me just pulling the data from the question and we just substitute that in. So the volume of the cone is equal to 1/3 multiplied by pi multiplied by r squared, which is 3 squared multiplied by 12. I'm just going to tidy up that square. Okay, in fact I should put 3.14 in there. Okay, now it's a case of understanding what order we can do multiples in. Okay, you don't have to do them the way you see it. So I can do 1/3 of 12 as my first step. Okay, So if I do a third of 12, it's just 12 over 3. Okay. So I'll just have pi times 9 times 12 divided by 3 is 4. And that makes it a little bit of a better equation to use. Okay, we've got rid of that third. Okay, we could have multiplied a third by 9 first and got 3. Okay, and then had pi times 3 times 12. Okay, so the order in which you do the multiples doesn't have to be what's laid out there. Okay, so I'm just going to put in that number for pi, so 3.14 we're given times 9 times 4. Okay, so now you need to pick that second part you want to multiply. So I'm going to take the 3.14 and multiply it by 4. Okay, we'll bring that over here. And I'll just do it in the column method. Okay, 4 times 4 is 16, carry the 1. 4 times 1 is 4, plus the 1 is 5. The decimal stays in line. Okay, and then it's 4 times 3, which is 12. Okay, so V equals 12.56 times 9. Okay, now we're doing the exact same thing. Now we're doing another calculation, which is slightly bigger. Okay, but the same rules apply. 9 times 9 is 81, carry the 8. 9 times 5 is 45, plus the 8 you carried. Okay, 45 plus 8 is 50. Don't know why I did 59 there. Sorry. Scrub. That's 56. That's why it wasn't working. Okay, let's start that again. 12.56 times 9. You can see how easy a mistake is. 12.56 times 9. 6 times 9 is 54. Carry the 5. 9 times 5 is 45. Plus the 5 that you carried is 50. Remember, the decimal stays in the same position. The decimal goes in there. Okay, it doesn't change the process what we're doing. 9 times 2 is 18, plus the 5 that we carried. Okay, that gives us 23. 9 times 1 is 9, plus the 2 that we carried gives us 113.04. And it's a volume, so it's cubed. That's our answer. You need to be able to do this. Okay. Surds. A lot of people did a lot of good things with this question. A lot of people started it correctly and went off in random tangents. Okay, so what you want to do is split up all your terms, simplify them as far as possible, okay, to be left with the same surd. And when we've got the same surd for all these terms, we can simplify it down. Okay, so that last term there, that 3 root 5, that's a clue what you're looking for here. Okay, we're looking to end up with a bunch of root 5s. Okay, so we're looking to split up this and this and be left with something root 5. Okay, So the rules of surds, this is section 2.5. We can split up the inside number as a multiple. So 9 times 5 in this case, minus the root of 4 times 5, plus nothing happens to that final term. We can't break root 5 down any further. We can't simplify that any further. Okay. That means root 9 times root 5, root 4 times root 5, 3 root 5. Again, nothing happens to that. That root 9 simplifies down into 3, root 4 simplifies to 2. Now we've got root 5, root 5, root 5. They are like terms, so you can add them as normal. Okay, so we're going to be 4 root 5. 3 minus 2 plus 3. That's it. Next question. A lot of you picked up the fact it was simultaneous equation. Okay, so they wanted you to do this process for simultaneous equations. So a lot of you picked up on that and just got lost a wee bit along the way. Okay, now it's actually quite good to look at what they can do with simultaneous equations. So if I've still got that document open somewhere. Okay, so solving equations, simultaneous equations, okay. Don't give you much here. Okay, but there's a few different directions in which they can take this. Okay, so it could give you a wee story about finding missing variables, so finding the cost or finding, I think we did one with the number of seats in a theatre. Okay, you could do that, give you a wee story behind it, or they can work out the process. If I give you a bit of this. Or they could do it as we've been given here. Okay, find the point of intersection with the lines in the equations. Okay, so what you've been given is two straight line equations essentially. Okay, so if we were to draw these as a graph, these two lines would intersect each other. We're looking for the point of intersection. So when both their x's are equal to the same and both their y's are equal to the same. Okay, so we're doing simultaneous equations to find our missing x and missing y. Okay, let me explain that a wee bit. If we had a graph x, y, okay, what we've been given is two straight lines. Okay, now you don't need to work out what the gradient is, what the blah 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 is. What they're looking for you to find out is what this point of intersection is. So at what point do those lines have the same value for x and the same value for y? They're looking for that coordinate. Okay, so with 3x plus 2y equals 5 and 2x plus 5y equals -4, they're looking for you to work out what x and y is when those lines are at the same point. Okay, we're going to do simultaneous equations, which a lot of you picked up on. Okay, and we're going to do it by elimination. So we're wanting to try and eliminate either the x or y term. Okay, so to do that, we need to multiply the top line by 5, the bottom line by 2. That's going to give us 15x plus 10y equals 25. Remember, you need to multiply every single term. Okay. And the bottom would be 4x plus 10y equals negative 8. Okay. Then we're going to put a wee line below that. Okay. And we can either add both these expressions together or take both these expressions away from each other. Okay. So I'm going to take this away, and that will eliminate the y term. So we're doing 15 minus 4, which is 11x. 10y minus 10y is 0. And then 25 minus 8. Okay, so 25 minus 8, which would be 25 plus 8, which will give us 33. Okay, so we've got 11x equals 33. That means solving for x, 33 over 11, x would be equal to 3. Okay, so we've eliminated the y. We can then sub into expression 1, okay, which was 3x plus 2y equals 5. Okay, we're going to substitute x equals 3 and where there's an x. So we've got 3 multiplied by 3 plus 2y is equal to 5. 9 plus 2y is equal to 5. 2y is equal to 5 minus 9. 2y is equal to minus 4. Minus 4 divided by 2. Y is equal to minus 2. So your coordinate of where these lines intersect, where these lines meet, is when x is equal to 3 and y is equal to negative 2. Okay, simultaneous equations. Now we could have started this, okay, by eliminating the x, and that's perfectly fine. Okay, exact same process to eliminate the x. We multiply the top line by something and the bottom line by something to get the same x term, and then we need to either add or subtract the two lines together to eliminate that. Okay. Okay. So we start off with the same. We multiplied that by 2, we multiplied that by 3, 6x plus 4y equals 10. 6x plus 15y equals negative 12. Line underneath that, take both away. 6x eliminate. We'll end up with 4 minus 15 is negative 11. Okay, 10 minus 12 is negative 2. Overdone. Okay, that's a complete lie. It's not negative 2. It is 10 minus 12, which will give you 11y equals 10 plus 12, which is 22, equals 22. So with that, 22 over negative 11, y equals negative 2. Okay, and then we'd sub that in, expression whatever you want. Okay, so 2x plus 5y equals -4. So if we substitute that y into here, we'd have 2x plus 5 multiplied by -2 equals -4. 2x minus 10 equals -4. 2x equals -4 plus 10. 2x equals 6. X equals 6 over 2. X is equal to 3. And we get the same answer. Over here, look, y is intercept. So you can either eliminate x or y term. Okay, you can eliminate the x or y term. Okay, so most people started that okay and then went crazy. Next question, question 10. Probably single worst question done across the whole paper. Okay, probably one of the easier ones. Okay, all you need to do is draw out the cost graph and then look at where cost 90 is, cost 360 and cost 180. Okay, so cost graph between 0 and 360. Okay. So the cost graph has a milestone at every 90 degrees. The cost graph at 0, when x is equal to 0, has its highest point. It then crosses at 90, hits a minimum at 180, starts to go back up, crosses 0, x equals 0 again at 270, and finishes at maximum point at 360. Okay, so drawing that out. Cost graph. Okay, it's not perfect, it's not bad. Look back at the question. Order the following from the smallest to largest values. Cost at 90 equals 0. Okay, so what is the value of y when x is equal to 90? So we've gone along the x-axis to 90. What is the value of y? That's what it's asking you for there. What is the value of y when x is equal to 360? So when x is equal to 360, y is equal to 1. And when x is equal to 180, y is equal to -1. So it's about knowing the shape of the graph, and it's about knowing what the milestones of the graph are. Okay, and not overthinking it. So when it's x equals 9, the cost graph is equal to 0, y. Okay, the y value is equal to 0. So if we're doing that from smallest to largest, okay, cost 180 is your smallest. Okay, then it goes to cost 90, then cost 360 is your largest. Okay, so that's section 21, and we just have to know our trig graphs. What is the shape of a sine graph, and where are the milestones? What happens every 90 degrees? Okay, question 11. Solve algebraically an inequation. Okay. Question 11. Solve algebraically the inequality. All we're looking for is to get to a value of x. So we're wanting to break the bracket up, and we're wanting to rearrange to get a value for x. So we want x is greater than or x is less than a number. Okay. Jesus Christ. Okay, so first step, I'll just break the bracket up. The important thing with inequalities is knowing what to do with this. Okay. So I've just tidied it up. I've just broken the bracket, and I'm left with x terms on one side. Oh, sorry. I'm left with an expression on one side and an expression on the right hand side. Now I want to get all the x's onto one side and all the whole numbers onto one side, and then allow me to solve. Okay. So I want to end up with my x on the left hand side, so I'm just going to do that. Okay, so I'm going to bring this 7x over here, and I'm going to take this number over here. Okay, so it's going to give me 3x minus 7x. Nothing happens with this symbol yet. Okay, we're just rearranging addition and subtraction. So we're taking over that 22 at the same time. Be careful with the symbols here, because that'll be -8, -22. So that'll give you -4x, -30. Okay. Here is where you might lose it. Okay. If we're moving a negative over to become a divide on the other side, this flips and goes the other direction. Okay, a negative divided by a negative gives you a positive. Okay, so x is greater than 7.5. So the x value for that expression to work has to be greater than 7.5. That is the key step. Moving a negative from one side to another changes the symbol in an inequality. That is the one only sort of big rule that we need to know for inequalities. Question 12. Was that? It was okay. Okay. So rearranging. Okay, worth 3 marks. It's worth quite a lot of marks for not a lot of work. Okay. So first thing we want to move is this D. It's positive on the left hand side, so it becomes negative on the right. So you're left with that whole term. Oh, sorry. Start off, we're rearranging for E. Okay, so we're rearranging for E. So we want E left on its own on the left hand side. So D moves across, F minus D. Okay. We need to then get rid of this root and move that across. When we're moving that across, it squares everything over on the right hand side. So you need to put that bracket. That is a really important step there. Okay, it's squaring everything in that right hand side. If you write this, that is wrong. That is you squaring only that D term. What this is showing is everything in that bracket is being squared. Okay. So when you're moving that root across, you need to make sure you put a bracket around everything on that right hand side and square the whole thing. Okay. Then the final step is bringing the 3 across, like so, and that's it. 3 marks. That's section 16.3. Okay, question 13. On the whole, it was pretty poorly done. And I'll take the blame for that, I think, in the way it's explained. So functional notation. There's 2 ways in which they can ask you this. Okay, so this is obviously one way. Okay, so we're looking for values of A. Okay, so what could this value be to allow us to get to negative 18? Okay. What could that value A go into there to get to negative 18? Okay, so we're looking for that to change. Okay, so we substitute something into there to allow us to get to negative 18. Okay, so the function for x negative 10 equals negative 18 when x is equal to A. Okay, so we're substituting in our letter in there and solving for that letter A. Okay. So just going through that then, 4a equals negative 18 plus 10, 4a equals negative 8, a equals negative 8 over 4, a is equal to negative 2. Okay, so if I put in negative 2 into that original function, I'll get negative 18 out. Okay, so another way to write that would be f negative 2 equals 4 equals negative 18. Okay. So it's looking for the value of that letter A to allow us to get to negative 18 from that expression. Okay, so this is your start and this is your finish. You're looking for that value in there to allow this to be your outcome. Okay. So that is section 13.1. Okay, so they can ask it two ways. Okay, they don't need to use the letter F, they don't need to use the letter X. Okay, the first way they can ask it is when you get given X equals something and you substitute that into the function. Okay, what the question we just did there is we were given B. We were given an answer, so that function is the answer. Okay, and you're looking to find out what number we need to substitute in to get to that answer. Okay, so what do we need to put in that position to get to equals 29? Okay, so we need to do that function equal to that and then solve for the missing letter. So that part B is what we got given. Okay, they can ask it in two different ways. Okay. Question 14 should be a nice, quick, easy one. It's just your rules of indus. We'll say, okay, so section 3.8. Section 3.8, your indus rules. Okay, this one here. Most people did the first bit, okay, and then didn't really understand what it meant by leave with a positive power. Okay, 14. Okay. So most people sort of got to here and then just made the next step up. Okay, what they're looking for you to do with this is understand that a negative power becomes 1 over x to that power, and that leaves it in a positive. Okay, which is this rule here. So if you've got a term to a negative power, you can write that as 1 over that power that the power becomes positive. Okay, so an example there, 2a to the negative 3. That a to the negative 3 can go in the bottom and become a positive power. The 2 stays in the top. Okay, we've got something like this, a to the minus x. The minus x goes to the bottom and becomes a positive power. Okay, so if we've got x to the minus 12, then to leave that in a positive power, we put that minus 12 to the bottom. That's it. Question 15. Let's see if I can draw this. Not really. Okay, so this is what you're given in the question. Most people had a go at this, which was good to see. So most people were able to pick up that, okay, this isn't a right angle triangle, so we need to use one of our rules, okay? And most people was able to pick up that because there's that sign B there, then the rule that we're using to find the area is the one that's given in the front of our paper, which is half AB sine C. Okay, so here's when we went a bit skew. Remember, the letters in the question, more often than not, will not relate to the letters that you're given in your standard form for your equation. Okay, what you need to know is what side that you want to label as A, what side you want to label as B, and what angle you want to refer to as C. Okay, so this is where you sort of need to know where we're doing those matching pairs. Okay, those matching pairs are really important. So if I was looking at that angle, the matching pair for that would be over here. Okay. If I was looking at that angle, the matching pair is over here. And if I was looking at that angle, the matching pair is over here. Okay. So we are given in the question sine B. So we are given a term for this angle here. Okay, so we need to use this instead of that. Okay, and that throws a lot of people. Okay, the fact that they're using different letters. But we want to put sine B where that says sine C. Okay, Again, the letters in the question will not, or very, very rarely, will be the same letters used in the standard format. So the standard format you're given in the equation sheet, the formula sheet at the front of the paper, the letters won't always correspond. That's why you need to be really clear when you're talking about matching pairs. So we are now focused on this angle here. Okay. Sine B over 2 over 5 will fit into this position. Okay. When we're working out the area, is the best way to describe them. The two sides that we're using have to be the sides that aren't the matching pair to this angle. Now it doesn't matter if that's A and C, or if that's A and B, or if that's B and C. Okay, it can't be one of the sides which is a matching pair to this angle here. Okay. What else has to occur is the fact that that sine B is equal to 2.5. Sorry, that's a complete lie. Is equal to 2 over 5. Okay, so where that says sine of the angle, you just have to substitute in 2 over 5. You don't have to substitute in sine 2 over 5. So that whole term is removed and 2 over 5 gets put in place of it. Okay, so that's hell of a messy. Let's write it out. So the area would equal a half multiplied by 15 multiplied by 10 multiplied by 2 over 5. Okay. Sine of the angle, and I've used the letter B, is equal to 2 over 5. So you remove that whole term and substitute in 2 over 5. So you don't have to do, remember this is a non-calculator, so they're not going to have to do in your head sine of a fraction. You can't do it. Okay, so you need to remove that whole term and substitute in 2 over 5. This we can do. And again, it comes to the order in which you want to do the multiplication and dividing. Okay. So, a couple of ways we can do this. Maybe tidy it up a wee bit, multiply the half by the 10. Okay, 10 over 2 just gives us 5. 10 over 2 would be 5 multiplied by 2 over 5. Okay. We can do 5 multiplied by 2 divided by 5. Okay, so we can just do these two bits. So 5 multiplied by 2 is 10, divided by 5 leaves us with 2. The area will be 30 centimetres squared. This up here is the confusing part. If they didn't use the letters A, B, C, it might have been a wee bit easier to sort of decipher. The fact that they used letters A, B, C made it even more confusing. Okay, But what you're looking for is matching pairs. Okay. (16) identities. So by considering the left-hand side, that's where we're starting. Show clearly that that can become that by using our identities. You have to remember what the identities are. You're not given them in the paper. Okay, so this is section. No, actually noted it down. Check. 21.4. Okay, so these have to be remembered, these identities. So where we see tan x, we can substitute in sin x over cos x. Or when we see sin squared x plus cos squared x, we can substitute in the number 1. Okay, so we need to remember these two identities. And then we need to know that we can substitute in where we see part of it, we can substitute in the rest. Okay, so just copy these identities down so we've got them, so we know which one to use. Okay, so question, considering the left hand side, so we are going to use one of our identities on the left hand side and then cancel it out and tidy it up to try and be left with this cos x. Okay, so our identities, the two identities we need to know are tan x equals sin x over cos x, and sin squared x plus cos squared x equals 1. So we need to use one of these on this left hand side. Okay, to finish up with the right hand side. Okay, now what have we got on the left hand side? Well, we've got sin x and we've got a tan x. So we can substitute in identity 1. Okay, so where it says tan x, we can substitute in sin x over cos x. So that tan x can be changed to sin x over cos x. So we're substituting in identity 1. Okay, and that will leave us with sin x over sin x over cos x. Now, that looks odd. Okay, however, if you've got a fraction on the denominator, you can take, okay, so if you've got a fraction as part of a fraction, if it's in the denominator, you can take that bottom term and flip it up to the top. Okay, so if I put this another way, if we've got 2 divided by a quarter, okay, we can write that as 2 over a quarter. What we can do with that is 2 times 1, oh sorry, that's wrong, 2 times 4 over 1, so that would give us 8. Okay, so if you put that in your calculator, just to try it, 2 divided by 1/4, you should get 8. Okay, so that's what we're doing. Okay, so if you've got a fraction and you've got a fraction at the bottom of that fraction, you can take the bottom term and put it all the way up to the top. So that will become sine x cos x over sine x. So we've taken that cos x and we've put it on the top line. Okay, that means that sine x and that sine x can cancel each other out, and we're left with cos x. That's the answer. Okay, so we're substituting in one of the identities. So tan x can also be written as sine x over cos x. If we've got a fraction in the bottom of a fraction, we can move the bottom line all the way to the top and it becomes a multiple. Okay, it's quite a hard one to grasp, so do it in an easier way. Okay, and that's why I did it. Yeah, okay, it's that process there. If we've got 2 divided by 1/4, you could also write it like that. That 4 can come all the way up to the top, we get left with that. That's all we've done here as well. Okay, that is the end of the question paper. Full marks. Boom. Okay. The biggest thing I've seen is that idea of substituting something in. Okay, so we've got x equals to 3, taking that 3 and putting it into an expression wherever there's an x term, or tan x equals sine x over cos x. Well, we can take that sine x over cos x, and wherever it says tan x, we can put that in. Okay, so substituting into an equation is a really important skill. Okay, so if you don't understand that bit or you can't see it in some places, ask me the question. Okay, that area one, especially when we were finding the area of the triangle ABC, that is a tough one to grasp just because they threw in the letters that they used. Okay, making it even tougher than it had to be. Try and grasp that one because there's always a rearranging part of it. Okay. So substitution. Okay. If you don't get it, ask me, please. Cheers.